Directional orbitals like P and D have shapes that make electron density uneven. And when these orbitals overlap, they force bonds into specific directions, producing characteristic bond angles and molecular shapes. Think of orbitals as clouds around atoms where electrons live. Some clouds are round, like spheres, and others are lopsided, like dumbbells or clover leaves. And the lopsided ones point in particular directions. When two atoms form a bond, the parts of their clouds that stick out meet and overlap. So the atoms arrange themselves so those pointing parts line up best. That means if an atom uses p orbitals for bonding, its bonds tend to be at right angles, or 108 degrees depending on how many bonds there are. And if it uses d orbitals, the bonding directions can be even more complex. The uneven directional shapes of these orbitals make the electron cloud thicker along some lines and thinner in others. And the molecule settles into the geometry that keeps these electron-rich regions as far apart as comfortable. A common mistake is thinking all orbitals are spherical, which makes people predict wrong shapes. Remember, p and d orbitals have lobes that point and change angles. Another error is assuming lone pairs do not affect geometry, but lone pairs occupy directional orbitals too and push bonds into different angles, so count them when predicting shape. Some students try to use only electron counting without considering orbital orientation, and that misses how overlap direction changes bond strength and angle, so always think about where the lobes point when you draw a shape. For more videos and resources on how orbital shapes determine molecular geometry, visit www.gumballdegree.com.